Rightio. Yep, that's right. That was embarrassing. Okay, so by way of revision, okay, Year 9, ionic bond. Now you should take out your periodic tables for this. An ionic bond, the definition is for a metal cation, one of those metals on the left of the periodic table, to donate an electron or electrons. And a non-metal anion, the non-metals are in the jigger of your periodic table, to accept electron or electrons, and then they will stick together because of electrostatic attraction, that positive and negative attraction, and they will form a salt, and that salt takes the form of a crystal lattice. So you don't just have, you never just have sitting around a molecule of sodium chloride, just two atoms stuck together. You know, you have many sodium stuck to many chloride atoms in this sodium chloride crystal. And the crystals are large enough for you to see, and you see them as grains of salt. But there are obviously many different kinds of salt, because all ionic bonds are forming those salts that have a crystal lattice shape. Now, for covalent bonds, which is the Year 10 bond that we covered the other day, it's a non-metal bond. So there's no positive and negative charging involved for attraction to occur. So the crying baby, there were those two key things that we talked about in terms of why atoms form molecules. They want to be electrically neutral, and they want to have a valence shell that matches that of a noble gas, which is usually 8 electrons in the outer shell. So for the non-metals in your periodic table, they will share electrons with other non-metals. And the example here is carbon. What group is carbon in? What group is carbon in? It's in group 4. Yeah, it's in group 4. So how many valence electrons does it have? 4. It's not a trick question. If it's in group 4, it's got 4, it has 6 electrons, but 2 of them are in the inner shell, the K shell, and we're not interested in them. We're only interested in those valence electrons in Year 10. So carbon has 4 valence electrons. Now how many electrons does, and they're in the L shell, or may as well put a little L there for L shell. There's a K shell inside, but we're not interested in that. It's got 2 electrons in it. And how many electrons does hydrogen have in its valence shell? It only has that 1 electron, and that's in which shell? The K shell. It only has a K shell, and it has 1 electron in each case, in its K shell. And by sharing electrons, carbon's in group 4. It wants to have 8 valence electrons, so if it's in group 4, it needs to share 4 electrons. So these carbon electrons sometimes go around to hydrogen, sometimes go around the carbon. So every so often, carbon has 8 electrons in its L shell. And these shared electrons here, hydrogen has 1 electron in its outer shell. It wants to get 2, so it's similar to helium, has a noble gas configuration of helium. So it has 1, so it needs to share 1. And that's what each hydrogen is doing. And those hydrogen ones are also going around the carbon. And so you get this electron sharing going on with a covalent bond. And the same over here for oxygen. What group is oxygen in? 6. It's in group 6. So it has 6 valence electrons, and we tend to draw them like that. If it has 6, it needs to share how many electrons to get electrons shared with it? Yeah, it needs to share 2 electrons, so something will share electrons with it back. So it shares 2 electrons with hydrogen. Hydrogen's pretty common. And in doing so, the hydrogen shares electrons with the oxygen, and you get this particular bond forming. Ammonia is in which group? Which group is ammonia in? Oh, sorry, not ammonia. Nitrogen. Which group is nitrogen in? 5. It has 5 valence electrons. It wants to have 8. It needs to share how many? 3. It needs to share 3 in order to have 3 shared with it. So nitrogen, those ones there, and the hydrogen will share in each case, and you'll get another covalent bond. So by way of revision, your periodic table should look something like this. Right, on your periodic table you've got some notes. You've got your groups, which we had 1A, 2A, 3A, 4, 5, 6, 7, 8A. Now, where are the most reactive elements in the periodic table? The most reactive. Bottom left. So you've got an arrow here, actually, not too close. You've got an arrow here with increasing reactivity. And we have an arrow across the top with increasing reactivity. So the noble gases, of course, don't react in any meaningful way. And so you have least reactive in this top corner. You should have the jigger. What does the jigger indicate? The non-metals here, just in this little corner. And you have the metals all the way through everything else. The group 1 have how many valence electrons? They have one valence electron in every case. And how many electrons will they donate in reactions? Yeah, they'll donate one electron. So these two, that will donate one electron. And what ion will it form? It will have what charge when it donates an electron? Yeah, it'll form a 1 plus ion because it'll have one extra proton compared to electrons. The group 2s will donate how many electrons? Not a trick question. Going to be 2 electrons. And so what charge will they have? It'll be a 2 plus charge. The group 3 will donate how many electrons? 3 electrons. And we'll have a 3 plus charge. Group 4 we do in a little bit. Group 5, 6 and 7. Group 5 accept how many electrons? Yeah, they will accept 3 electrons. So these guys here will accept electrons. And it is accepting 3 electrons. So what charge will it have if it accepts 3 electrons? It'll have, yeah, a 3 minus charge, a 2 minus charge, and a 1 minus charge. For 3 electrons accepted, 2 electrons accepted, 1 electron accepted. Okay. Now, for the group 4, 5, 6, group 4, 5, 6 and 7 also form covalent bonds. So you actually have to have that additional information up there. Group 4 share how many electrons? Yeah, group 4 share, I'll put up here, share 4 in group 4. Group 5 share how many? 3. Group 6 share how many? 2. Group 7 share how many? 1. Hydrogen is part of that jigger as well. And so hydrogen can interact and it will also share 1. Okay? And so hydrogen can work on this side of the periodic table as a covalent bond or as an ionic bond. So your periodic table should contain approximately that information, where the non-metals are, the number of electrons they share, because all of the elements in group 4 will share in the same way. And the elements in group 5 will share in the same way, 6 and 7. They'll all follow the same patterns. You've got your reactivity, you've got how ions are formed, which are electron donors. The metals donate electrons and get a positive charge because of it. The non-metals accept electrons and get a negative charge for it. So your periodic table should have that much, and you should be able, looking at a periodic table, to replicate that information, because in the exam you'll get given a periodic table. Yeah? You can't take your one from class in, but you will be given a periodic table, so that if you get asked a question that means you have to work things out a little bit, like covalent bonding and things like that, you should be able to work that out. Does anyone have any questions about that? So these ones here both accept electrons for ionic bonds and share electrons for covalent bonds. Okay, now back here, right there, we had a look at that exercise the other day. This is the new stuff, so I need to take a couple of notes. This is just an overview of, now you don't necessarily need to write this down because I think you probably know this at this stage, that these are the properties of an ionic compound. Now, they are a non-metal and a metal bond, ionic bond. They transfer electrons, they have charges involved. Don't worry about the names, that's not important at all. They're solid at room temperature and they have high melting and boiling points. Okay, whereas a covalent compound, non-metal, share electrons, no charges, don't worry about the naming, solid, liquid or gas at room temperature. So slightly different in that respect. Low melting and boiling points. So the bonds aren't as strong, if you like. Weak attraction between molecules, high attraction between particles. You had a question?
Yeah. In ionic bonds, is it always the electrons that are transferred from the metal to the non-metal?
Yeah. Always transferred from the metal to the non-metal, and it's that electrostatic attraction that holds them together.
Loses electrons.
The metal loses electrons. The metal is an electron donor. And you can see that when you look at the periodic table, the metals are on the left over here, and they want to have that electron configuration like a noble gas, so they need to get rid of electrons in their valence shell, and so they donate electrons. Okay. Now, this is Bohr configuration or Bohr diagrams you did last year. That's where you show the nucleus and you show the electron shells and the electrons in each shell. Okay, you did that sort of thing last year. That's what a Bohr diagram is. Show where electrons are found in different shells. Electron configuration, you need to review that quickly. It's just a numeric representation of where electrons are. Like you have in the carbon atom here, we have 2 electrons in the K shell and 4 in the L shell. And the electron configuration, carbon, 2 electrons in the K shell, comma, 4 electrons in the L shell. So as far as, if you get asked a question, write the electron configuration or the electronic, some textbooks say electronic configuration, that's what they're referring to, this idea. So you'll need to take a note on that. Electronic configuration is just a simple representation of what's happening with electrons, and a Bohr diagram, which you won't be asked to do, shows all of the electrons in the circularized orbits. Okay. Can I change? Yep. Can I change? Yeah, all good? Right, this is what you will be asked to do. This is the new stuff. A Lewis structure or a Lewis dot diagram, and if the person writing the exam is feeling generous, they'll say Lewis dot diagram because then it helps you remember. Oh yeah, I need to do dots to show electrons. Now carbon has 6 electrons, 2 in the inner shell and 4 in the valence shell. And in a Lewis dot diagram, you're only showing the valence shell electrons. I keep saying that for year 10. We are only interested in valence shell electrons. So you just do the symbol, carbon, and you do the dots. Okay? And for lone pairs, is this idea, non-bonding pairs of electrons need to be shown in these diagrams. Here's a molecule, water. Oxygen is in group 6. How many valence electrons does it have? 6. Not a trick question there. There are 1, 2, 3, 4. See how I've got these in pairs? And there's 1 oxygen one there and 1 oxygen one there. There's our 6. And in this covalent bond, they are sharing electrons with hydrogen. Hydrogen has 1 electron in its outer shell. So I'm doing noughts and crosses to make it a bit more obvious to you, but you'll just be doing dots. Okay? So that's a Lewis dot diagram of the molecule for water. Now you need to show those lone pairs. You really need to show those lone pairs. You lose half a mark in every instance that you don't show lone pairs. Okay, so be aware of that in your diagrams. So that's a Lewis dot diagram. The octet rule is the one we looked at before. When atoms form molecules, they do so, they lose or gain or share electrons in their valence shell so that they ultimately get a configuration of 8. Question?
Yeah, how does the lone pairs work?
The lone pairs, these have opposite spins, so they can be, if you like, be proximal. It just makes it easier to keep track of things, because if you have single dots around molecules, it's hard to keep track of things. Okay, and we'll be using these later in our next unit of work. Okay, can I change slides? No. Okay, that's okay. So you do need to have Lewis structures. Okay, you do need to be on top of Lewis structures, and we'll be drawing some Lewis structures today. And the last one we'll look at is structural diagrams, okay, which always appear on the exam. It's unavoidable, because when we do hydrocarbons, you need to draw them as using structural diagrams. Okay. Change now. Yeah, Octet rule you should have from earlier. Okay, so the last one is structural diagrams. They show the same information that you saw previously. It's about electron bonding in covalent molecules or covalently formed molecules. But instead of showing the shared electrons as 2 dots, you show them as a line. Okay? So oxygen has 6 valence electrons. So 1, 2, 3, 4. Now there's another one here and there's another one here. If this makes it easier, you can start off by doing this. There's our 6 for oxygen. Hydrogen has 1 valence electron, so that might be here if you like. And this oxygen electron is shared with the hydrogen. This oxygen electron is shared with the hydrogen, and vice versa. And then just draw a line between them. Okay, and that is just a faster way of drawing molecules. The line shows a single bond. Now, if you have a double bond, you would draw 2 lines. Okay, so we saw nitrogen gas. Nitrogen gas before. Nitrogen's in group 5. How many electrons does it want to share? 3. So nitrogen can bond to another nitrogen. It will share 3. And then each nitrogen will have 2 left over as a lone pair. You follow that? There's 1, 2, 3, 4, 5 for that nitrogen. 1, 2, 3, 4, 5 for that nitrogen. But instead of drawing little dots left, right, up and down, we just draw lines. Okay. Once again, lone pairs must be shown. Okay. You'll get sick of hearing that, but it's necessary. Now let's see. Any questions there? Yes?
So that's not a Lewis structure?
No, a Lewis dot diagram just uses dots. But a structural diagram uses lines. Yes?
So each line is like 2 electrons?
Each line is 2 electrons, 1 from each atom, either side of that line. Okay? Any other questions? We're going to draw some structural diagrams now. Okay? So I'll give you a moment to finish that. I think